Okay, this video we're going to look at this question which we've created. It's on geologic geometry, but within the topic of geologic geometry, this question is on road geometries. So, A to B is a road of formation width of 16 meters, which rises from A to B at an inclination of 1:13. A and the roundabout are at a level of 45 meters, using slopes of 1:1.5 for cutting and 1:2 for embankments. Complete the drawing of the north side of the road. So we want to decipher this question. So A to B is a road. Okay, you see your 2 points. Formation with 16 meters. That means the width is 16 meters. So this drawing is scale of 1:100. I should have added this in. That's to 1,000. Sorry, yes, 1,000. So 1:1000 scale. So means that 16 meters in this drawing is represented by 16 millimeters. So what I can do now is draw in two lines which are 16 millimeters away from A and B, parallel with the center line. Parallel with the center line. So I'm going to go up 8 because this is half of the road. AB is the center line, so I'm going to skip out that. Now I'm going to go from A and I'm going to go up 8, enter, skip, and now I can join A to B. Well, more specifically, I'd be joining A to the roundabout, or B to the roundabout there, like that. Okay, so I can just get rid of that line now, and I can get rid of the B line that's there, that line there. Okay. So now I'm going to I can copy that onto the other side of the road as well. Okay, so that's one side of the road. So we are more interested in the north side. So it's sloping at 1:13. So what does that mean? So what that means is for every 1 millimeter, or for every 13 meters we travel along A to B, so every 13 meters the road rises 1 meter. So if we can imagine now, I just go into my model space and I'll go turn on snap. So I'll zoom in actually here now because it'll be easier to see. I'm going to go 13, enter, and then snap, and I'm going to go up 1. Okay. So if I join these points now, that is the slope that the road is built at. So you imagine this is A, this is B, or B is actually up here. Now if I want to go another 13 meters, 13, I go up 2 meters and join back. So this is exactly what we're doing. We're going 1 meter across, we're going 13 meters across for a 1 meter rise. So the easiest way we can look at this in the scape of this drawing is we want to get a rise of 10 meters. So what that's going to look like is we're going to travel from here 130 meters, right? I'm just going to delete my first sketch. And we want to get a rise now of 10 meters. And join it back to A. So this is going to be the slope of our road. 130 meters this way for a 10 meter rise. So we're going to come 130 meters from A to B. Going to go from A to B. And we're going to mark our point. So I should have it here. Now, right, now this seems like a lot to gather, but I'll explain it. Okay, so we've come from A to this point here is 130 meters, or in this case this drawing 130 millimeters. So we were always going to work from the edge of a road. because that's where the slope or that's where the cut or the embankment begins from the edge of the road. So this cone here, or this circle here, is representative of a cone. So we're going to use cut and fill cones for this. So this is representative of a cone. Now this cone is inverted, so which means it's upside down. So the high side is going to be facing up at us, with the pointy side digging into the ground. So this first one, right, the radius of this is 7.5 millimeters. This is down to the 1 is to 1.5 for cuttings, because our contour lines, as we discussed in my previous video, as we discussed contour lines, our contour lines are gauging or help us gauge the slope we need for our cuttings. So we can see our contour lines are in 5 millimeter intervals. If there's a difference between any lines, there's a 5 mil difference. So 60, 65, 60, 55, 50, 45, 45. So we want to do is multiply what, so we're going to take 5. What it is 1 is to 1.5, or if you were to think of it, 5 is 7.5, because 7.5 is 1.5 times 5. So we're going to use this of radius 7.5, radius 15, radius 22.5, and keep increasing your radius by 7.5 millimeters every time. So I've just drawn in 3 circles just to show, but all of these ones have a semicircle attached to them. Now we're going to look at this first one, 45. So this first cone is representative of the 45 meter contour line. So it's 45 millimeters from, it's 45 meters height. So we're going to join this line, the tangent. We're going to draw a line here from 45, or your contour at 45 on the road, to our tangential to this cone, or to this semicircle, as we see. So then this line is representing all that, and all points on that line, or if there's any point higher than that. So for example, 50 is your next contour, so 50, or this one's 55. That line is going to cut that point, because it's this one is greater, so it's going to cut into that. This one, alternatively 50, is going to be the same. Everything along that line has to be 50 meters. Everything along this line has to be 55. So, if you understand. So we worked all this way up as many contours as we need. So in this case, our maximum here is 75 millimeters, or 75 meters, sorry. So we're going to have a 75 contour line. So we trace all these points. We keep drawing these semicircles up and keep drawing tangential lines. And all these lines are parallel. Every single one of these lines is parallel to that initial line that we drew. That initial line, that first line we drew, is parallel to every other line on the way up. So when we have all them points plotted, we have to plot the points of intersection between these lines and their corresponding contour line. So in this case, this 75, this will cut in how many places? 1, 2. Because there's 2 contour lines at 75 meters, it will cross them at 2 points, these 2 points. As will the 60 contour line here along this way will cut our 60 representative 60 line, which is here, which will cut here. So I'm just going to put them in. So there's all our points plotted in the pink X's. So every contour is along that line, every point plotted, where the corresponding line here, or any of these corresponding lines, cross their matching contour line. So now that's basically part A for the moment. We can't complete it yet because there's a part B, or part 2. So part 2, CD, so I'll zoom out again so we can see it, the whole question again. So CD, so C to D, is a road leading away from the roundabout. So with a formation width of 18 meters, that means the width of that road is going to be 18 meters. which in the case of this drawing, you're going to go 9 mil either side to get your 18 meters. It is falling from C to D, so it's falling at a slope of 1:7. So using the same slopes as before, complete the western side of the road. So once again, similar thing. We're still going to use the 1:1.5 and the 1:2 for cuttings and embankments. But this time our measurement changes. So we're going to go from C to D. So as we can see with our contour line, C is also at 45, remember, because it's on the roundabout. So C is also on the roundabout, so it's also 45 meter height. So what we can look at is now it's going to fall from C to D at 1:7. So 1:7. So for this one, it was rising 1:13. So we came out 130 meters, which in the case of this drawing was 130 millimeters, to generate a 10 meter rise. So in this case, we're just going to do the exact same thing, only we're going to go 70 because it's 1:7. So we're going to go 1:7, draw in your formation width on your road, which is 18 meters. So I'm going to draw that here now. So I want actually perpendicular, so I do. Perpendicular is actually highlighted, yes, okay. So I want line, perpendicular. Tell you it was actually handier to do, actually no, I'll do it again here. Why is this not working? I don't know. Anyway, we draw our contour. I'll tell you, I'll copy this from this point and drag it out there. That's actually 18 meters because I've solved this question already and I have points resting in their correct positions. So I'm just going to turn the two of these into solid black lines, okay, just so they're more distinguishable. Okay, so that's the width of a road. So now what we want to do is do, once again, our cone, our cut cone, because our contours here are higher or bigger numbers than 45, so it's a cut cone. So I'm going to go and put in my cut cone again. Okay, so now we can see here. Now I know this might become a bit hard to see, but we've basically done the same thing again. We've drawn our 7.5 mil radius semicircles there, increased by 7.5 each time. Draw our contour, draw our tangential lines to them, which are all perpendicular to, or which are parallel to each other, sorry, and we're going to plot our points for them again. So now this time I'll show you, I've plotted the points. And if you can see this kind of maroon or brown coloured line, I've joined them all up. Okay, so I've joined them all up. So I've basically just joined them to show the link and the rough shape that will be. Okay, so we've got that in now, and we've got this side. So I might just draw in the matching line for the other side. Not that one, is this one. Okay, perfect. Okay, so we can see now these two intersect. So we've looked at the two of them, but the thing is we haven't figured yet is the cut and fill for the roundabout, because the roundabout from A to C has some cut as well. So we need to draw that in. Now a roundabout is level, so that means we don't have to use cut cones or fill cones. We can just work it as we normally would work a level road. So what that means then is we draw, I'll put it out, I have it done here. So what we have is come from center, we've come from a point that we know is 45. So here, right? So we know it's 45, and we've stepped out 7.5 because we're cutting again. 7.5, 7.5, so 7.5 and then on to 15. So that total weight is 15, representative of 50 meters and 55 meters. We've spun these around concentric to the circle. So they're using the same center point. So they're swung around until they hit their corresponding lines, or 50 or 55 meters, and we can draw them in. But if you look here, I've shown where there's I want to change one for this. So I've shown 55 meters, but we do not actually need that point, because the circle will initially be cut, or the ground will initially be cut at 50 meters and 50 meters, because all of this is going to be cut anyway, right? So all of here is going to be cut. So if I just draw in a spline here now, I can work from here out through the first 50, through the second 50, back to that point which I know is at 45. So this might begin to seem a bit complicated now, but we've three different lines. We've three different sets of cut lines here now. So we need to integrate these. So it's rather easy to integrate the outside one, okay? So how are we going to do this? What I'm going to do is I'm going to go, and I'm going to go into a layer. I'm going to go type A again, okay, right? So I'm going to go, no, I don't want line, I want a spline, okay, right? So I'm not going to do it all, because all of this is very time consuming, so I'm just going to go from here, okay? So we basically need to integrate the two of these lines. So it's this point through that point, and it's going to meet where it intersects, we hit it, square on, okay? Enter. Okay, so now you might think we go this, continue on, but we don't actually. What we actually do is we go and we just join, you follow the contour like that. So what oh sugar, that went wrong, just delete. So what I've actually done is just you join the two of them up like that. You'll see it in solution after. But down here is a bit more of a more complex matter, because we have three lines that we need to integrate. But integrating lines here is rather simple. We go draw, spline, and it's actually just this line is our cut line down here. There's no need to integrate the three lines, because everything after this line is going to be cut, as is everything inside. In this gap here, everything is going to be cut. So I'll show you a better solution in a moment, okay? So the third part of the question, complete the profile of the Earth from B to X. So we have B to X as shown here, the profile of the Earth, okay? So I'm just going to bring up the constructions, okay? So the constructions of the profile. So what we have here is we've gone B to X. We're bringing up every point where the line BX crosses a contour line brought straight up. And I've just drawn this line here, highlighted there, to just act as the baseline we work from. So what that is just our baseline. So the way we work this is, if that height is 65, we go up 65 millimeters from that point to that line. 70, we go 70 millimeters from that point, from that line to that point. 75 millimeters from that line to that line, and we join them all and we mark our points. To finish it off, then we just join every one of those points. So I'm going to show you the whole complete solution to this question now, right? So that line is actually not part of the solution, and that for a different mission, but we have all our lines joined up. So I'm just going to get rid of some of these layers or hide them, so we can see this somewhat better or clearer. So hide that, hide that. I'm going to hide that one. Oh, I'll leave that one actually. And the other blue one, D. So yes, now I've hidden some of these, and this is the way that we've joined our lines, okay? Now these uprights are actually where our B and X lines are spurring from, okay? So they're actually where B and X are spurring from, or are coming up from, okay? So I'll just hide that again. So now we can see where we've joined all our points. I want to turn on the other layer so you can see all our points. Yeah. So we've joined all our points there. We can see our pink lines all joined. And we've joined our maroon, your brown coloured ones as well. And I've just left in these two traces of our normal line. So that actually travels from there to that point, and they just join square on, while this one is also there. So that is basically how to solve this question. I want to get rid of that line actually, because I have them running already. So that is basically how to solve this question. And hopefully this video has helped you work out road geometry. Hopefully this video has actually helped you work out road geometry questions in terms of sloped roads, and also to help you figure out how to join up different cuts, or where two cuts meet, as well as work out profile of the earth. So thank you.